Hey everyone, welcome back to the channel. Have you ever looked up at the night sky and wondered if one of those little specks of light could be heading our way? It sounds like something straight out of a Hollywood movie, but the threat of an asteroid impact is something scientists take very seriously. So the big question is, if a giant space rock were on a collision course with Earth, could we actually do anything about it? Are we ready? Let's break it down. First, let's get a handle on what we're talking about. Asteroids are rocky, airless remnants left over from the early formation of our solar system. They orbit the sun, just like Earth does, but their paths can sometimes cross ours. Most are tiny, burning up harmlessly in our atmosphere as shooting stars. But some are big, we're talking mountain-sized. An impact from one of those could cause catastrophic, planet-wide devastation. The good news is, we're not flying blind. For decades, space agencies like NASA have been running dedicated programs to find, track, and characterize these near-Earth objects, or NEOs. Think of it as a cosmic neighborhood watch. Telescopes on the ground and in space are constantly scanning the skies, cataloging every asteroid that comes close to our orbital path. Projects like the Catalina Sky Survey and Pan-STARRS have found thousands of them. In fact, we've already identified over 90% of the truly massive, civilization-ending asteroids, the ones larger than a kilometer in diameter. And for now, none of them pose a threat. Phew! But what about the ones we haven't found yet? Or the smaller, city-killer-sized ones that are much harder to spot? This is where planetary defense gets really interesting. Finding them is just step one. Step two is figuring out how to stop one if it's headed our way. This isn't about blowing it up like in the movies that would just create a deadly shotgun blast of smaller rocks. The goal is to give it a gentle nudge, changing its speed and trajectory just enough so that it misses Earth entirely. The key here is time. The earlier we spot a threat, the less of a push we need to give it. If we find an asteroid years or even decades before a potential impact, a tiny change in its velocity can make it miss us by thousands of miles. It's like gently tapping a bowling ball right as it leaves your hand versus trying to stop it right before it hits the pins. One is a lot easier than the other. So, how do we give an asteroid that nudge? Scientists have some pretty cool ideas. The most tested method is the Kinetic Impactor. This is basically a high-speed game of cosmic billiards. We send a robotic spacecraft to deliberately crash into the asteroid. The impact transfers momentum and alters the asteroid's path. And guess what? We already did it! In 2022, NASA's DART mission that stands for Double Asteroid Redirection Test successfully slammed a spacecraft into a small asteroid moonlet called Dimorphos. It was a spectacular success. The mission proved that we can navigate a spacecraft to hit a small body millions of miles away and, more importantly, that the impact can measurably change its orbit. We now have concrete proof that this method works. But what if the asteroid is too big, or we don't have enough time for a kinetic impactor? There are other concepts on the drawing board. One is the gravity tractor. This involves parking a heavy spacecraft near the asteroid and just letting it hover. Over a long period, the spacecraft's tiny gravitational pull would slowly tug the asteroid onto a new, safer course. It's a slow and steady approach, but it's very precise and controllable. Then there's the more Hollywood option, but with a scientific twist, the nuclear standoff. This doesn't mean detonating a bomb on the surface. Instead, the idea is to detonate a nuclear device at a distance from the asteroid. The intense radiation would flash vaporize a layer of the asteroid's surface, creating a powerful jet of gas and rock that acts like a rocket engine, pushing the asteroid in the opposite direction. While it carries more risks, it might be our only option for a massive object on a short timeline. So, back to the original question, is humanity ready? The answer is, sort of. We're getting there. We have the technology to find most of the big threats, and we've successfully demonstrated a method to deflect a small one. Our detection systems are getting better every single year. The upcoming NEO Surveyor mission, for example, will be a space-based telescope specifically designed to find the majority of those tricky, medium-sized asteroids that could still cause major regional damage. The biggest challenge isn't just technology. It's international cooperation and preparedness. An asteroid threat is a global problem. It requires countries to share data, coordinate their space agencies, and agree on a course of action. Who decides which method to use? Who pays for the mission? These are complex political and ethical questions we need to answer before a crisis hits. Think of it like this: we've learned how to build fire extinguishers and smoke detectors. We even ran a successful drill with the DART mission. Now, we need to make sure every country has the equipment and an agreed-upon fire escape plan. We're not fully prepared yet, but for the first time in human history, we are no longer helpless spectators. We have the knowledge and the tools to protect ourselves. We are actively developing the capability to defend our planet. It's an incredible thought, isn't it? We've evolved from looking up at the stars in wonder and fear to developing the power to reach out and change their course. The work of planetary defense is a testament to human ingenuity and our collective will to survive. Thanks so much for watching and exploring this cosmic topic with me. If you found this interesting, don't forget to hit that like button and subscribe for more deep dives into science and space. Let me know your thoughts in the comments below. See you in the next video.